right, let's look at the copper coil demo. We're going to take a quick second and watch it. So as you can see, there's a piece of copper coil that is being heated up in boiling water on a hot plate. And that water is very, very hot. We're very close to 100 degrees there, boiling. We're going to use forceps to take it out of the water and put it directly in your hand. Wow, how is that possible? How did that not just burn the teacher? You would never put your hand in boiling water. How can you hold the copper coil after it just came out of boiling water? So let's talk about it. What happened? How can we use specific heat to explain this? Remember that specific heat is the amount of energy needed to raise 1 gram of a substance by 1 degree Celsius in temperature. Copper has a pretty low specific heat. 0.038 joules of energy is needed to raise 1 gram of the substance by 1 degree Celsius in temperature. Notice that copper's specific heat is much, much lower than water's. Water has a specific heat that's 10 times greater. 4.18 joules of energy is required for 1 gram of water to increase by 1 degree Celsius in temperature. So that's the important thing. Copper has a low specific heat. Not only does it take very little energy to increase its temperature for each gram by 1 degree Celsius, tiny losses of energy decrease its temperature very quickly as well. So even though the copper was 100 degrees Celsius when it was removed from the water, it lost a lot of energy as it's sitting in the room temperature air. And by the time the teacher, in just a few seconds, put it in his hand, it had decreased substantially in temperature because small changes in energy, it only takes 0.38 joules of energy lost for it to decrease by 1 degree Celsius in temperature. Hope this helped. Have a great day.